Biomedical. And I also want to thank my good colleague, Chris Erdman, who's also on today. He's one of the founding members of GoFair US, a collaborator on so many things, and a principal on the project that I'm going to describe. Okay, so as is the custom these days, I must get slides up to talk to you. But we have plenty of time. I prepared like an outline to kind of explain this project and our approach, keeping in mind how it might help inform similar projects that you might have. But I'd be also happy to open it up to discussion if there's time in the session, and have a couple extra slides in case people want to explore other areas. But yeah, I'm here to talk to you with it. The acronyms are so many that I didn't spell them out on the slide, but for those who don't know, NIH stands for the U.S. National Institutes of Health. It's the primary place that funds health and wellness in the United States and funds many things around the world. And they're divided into several different institutes, one of whom, I think it's the second largest, the National Institute for Allergy and Infectious Disease. And so I'd like to talk to you about the blueprint that we worked with them on developing. But again, it's not specific to NIAID. It's really an example of how to implement FAIR and research data management techniques in the biomedical sciences and really in science writ large. I do want to acknowledge, of course, the Office of Data Science and Emerging Technologies that funded this work through Leidos and the National Cancer Institute. And then, of course, the numerous people at NIH who gave their input and helped us make this such a successful project. And so I've got 3 topics and lots of pictures of infectious disease for your interest, since that is our topical area. Give you a little background on the project and how we got from the recommendations to the blueprint, and then a tiny bit on what's next, including things that you can take part in if you'd like. So Chris and I, and I'm sure a lot of you on the call, talk about FAIR a lot, and it is important to be committed to findable, accessible, interoperable data. But the real motivator is the science, right? And so this is just one example of why NIAID wanted to invest money and time into making their data more fair. It's to be able to do these really complex things. And so if you're wondering, why do people still have arthritis? Why have we not solved this? Well, it's a really complicated problem. And so one of the things that interoperable data can do is it can help build digital twins of complex systems, in this case, an arthritic joint. And there actually is a paper that talks about doing this in the bottom right from last year. But this is exactly the sort of thing that groups like NIAID, that other groups that are trying to tackle society's grand challenges want to work on. The reason that it is a grand challenge is there's over 1,000 biomolecules involved in what causes rheumatoid arthritis, the chronic synovitis. I hope I'm saying that right. For anyone who has knee trouble, you know, the synovial fluid issues. But to try and figure out the interactions between all of these different biochemicals takes many different researchers who are each studying specific and different things. So you've got to put all those together. But then beyond just the science, there are the motivations of the people running the repositories, right? To prove that the funding has been impactful, and also to make sure that those data products that you put out are used as widely as possible. And so, for example, one of the premier repositories on immunologic data in the world, Import, has many data reuse publications. But through even additional implementation of citation guidelines and outreach to users, we think that can be even higher. And Import is a great exemplar of this. There are many repositories that don't have citation guidance for its users, and so it can be difficult to track and find who was using the data that was produced and what was done with it. And so what we've laid out in this blueprint is one path towards that. The project vision from NIAID, again, does talk about FAIR, but it's not FAIR for FAIR's sake. It's about greater utilization of NIAID data resources to do things that are scientifically impactful in those NIAID research areas, and then creating that integrated ecosystem of tools and services um, that demonstrates the impact through the science impact. And so this is our team, which I collectively will refer to as GoFair US, but it is made up of several experts from around the world. We have people from the San Diego Supercomputer Center, Knowledge Motifs LLC, Chris Erdman, of course, who's part of both SDSC and SciLifeLab, and then Keith Mall and Matt Marinick at the National Center for Atmospheric Research in Boulder, Colorado, the group at the GoFair Foundation, and then other advisors as well. So just a quick recap, we've been working on this about 2 years. We launched the project 2 years ago, spent 2024 doing in-depth FAIR assessments, which I'll describe a bit to you, and then came up with a preliminary landscaping report that led to these cross-cutting recommendations. And then very soon after, we worked closely with ODSET, that Office of Data Science and Emerging Technologies, and they released a blueprint for FAIR implementation. We went through rounds of comment and refinement, and that blueprint was just published in September, 15 minutes before the government shut down. And then we've since launched phase 2, which is all about implementation of this and working directly with repositories on that. So overall, how we approached this was to start with foundations about FAIR, but also aligning it to the purpose of each of those individual repositories, right? Because they were founded with their own goals and longstanding practices. But then also take into account the institute-wide goals and things that had emerged, things like the emerging NIH persistent identifier strategy and things of that ilk. And then bringing those together and adapting based on our collective GoFair US team's experience from other projects and other domains. So our methodology, we knew there was lots of great work out there already. And we did try to use automated FAIR assessments. In fact, that was our hope that we could do that. But the data architectures were so diverse of the different repositories that was impossible. And we can talk about that in discussion if people want to talk about that more. But I think this is becoming a known thing that automated tools can work great if it happens to test for the one type of scenario that your repository uses, and otherwise it will just fail everything. So we look to the current scholarship out there, and these are some of the key pillars that we built around. Things from the Research Data Alliance, questions we had used with our previous project for the National Science Foundation with the EarthCube office, FAIR's FAIR, and a European Commission study as well. And this is all described and documented in something that we have put out as a preprint and is pending review at a journal, a persona-specific method to assess the fairness of data repositories. And so here's roughly what our process looked like. Again, we had hoped we could automate it. That's always the dream, especially in the age of AI, right? But it does turn out it's actually pretty complicated. And so we did the research that we could without bothering people. What is on their website? What's already documented? What data can we get access to look at? And then we developed this questionnaire, again, using some of the materials and kind of best of breed practices that I showed on the last slide, and sent a questionnaire to key people in that repository, technical people, coordinators, people who are more steeped in the science. We tried to get it from several different perspectives. And then once we had amassed that information, we figured out what we still didn't know and conducted follow-up interviews again with people from different perspectives. That was used to draft recommendations about the specific repository and then something that they could use to either support a supplement or justifying the work to their leadership. This is all documented in a repository profile, which is again discussed in that preprint from the last slide. And then this draft work plan, which this is just a quick screenshot, but some of the highlights on here, and I know this is small, but we talk about prioritizing, what the outcome would look like, which FAIR principle it maps to, how you could measure achieving this, and then kind of a cost benefit of how much effort will it take to do this so that people could really see, all right, here's some low-hanging fruit. Here's the stuff that would be most impactful. And I don't have it on in the slide deck for time, but we even have an example where we took one of these work plans and mapped it based on time and benefits so people could get a snapshot of their repositories challenges and where that was clustering. So we got a little more than halfway through the different key repositories, and we had been given, of the over 200 repositories at NIAID, a sampling of 11, which grew to 12. But that actually was enough to write a preliminary report. And so we had found a couple things that were helpful. NIAID, like all large organizations, is divided into subgroups that are clustered around scientific area or specific goals. And so we studied those repositories in those program groups. Sometimes they shared many dependencies and even flow of data. Sometimes, though, they just shared common goals. And so that was really helpful for looking at what shared approaches they might have, and even um, uh, discussing and evaluating things with them in groups. And there were a lot of synergistic opportunities. So where one group could improve something, that it would help others. There were a lot of common themes that emerged. And in fact, in our lessons learned, which I'll end with, uh, those common themes didn't change as we added more repositories. And so we knew we were really onto something. Um, we also knew that it wasn't just enough to say, here's how you do it, and that people could then take that and run with it. There needed to be some persistent work and engagement with the repositories, whether it was us or someone else, that there was a need for additional training, and even the socio-technical part, the change management. So here's a sample of the cross-cutting recommendations, and I haven't listed everything here, but you can at least see the 5 priority areas and their headings. So they were metadata, PIDs. The third one was machine actionable data, which was a combo of have an API and exposing machine readable metadata. And then impact, which was like that, one of those first motivating cases of, you know, citation guidelines so that you can track impact. And then one about outreach and training. Again, getting at some of those things I mentioned on the last slide with change management, the socio-technical part of initiating change. We realized that our deep dive approach was effective, but 200 repositories, it was going to take a very long amount of time, even if we could figure out how to scale this. And some of the reason was it was a bit too detailed. You really did need experts for most of the work. There's a little bit of what I call maybe easier work, but not much of it. And it wasn't just short, whimsical conversation. It was deep thought that was needed by both parties. And so we looked at the preliminary landscaping report. We did a lot of soul searching and thinking with our project sponsors about what to do next, and came up with a new approach, which we realized, okay, we have learned a lot that was important to know. And we're now steeped in the context of the repositories that we're working with and the goals of this organization. But we thought it was time to pivot and look at what are the common recommendations, how can we work with customers to find what they're going to target, and give them really concrete guidance that we can then get community feedback on and adapt over time. And so the result of that, and again, this is in partnership with that Office of Data Science and Emerging Technology at NIAID, is the NIAID blueprint for including digital objects in the NIAID data ecosystem, or as we just call the NIAID blueprint. And so it has 5 areas. Many of our recommendations made it into the blueprint. One that is perhaps a little smaller was the machine actionable section, stepped back just to focus on APIs. And that was a judgment call about the readiness of the community, and as well as the high benefit that there would be by making it simpler and focusing first on APIs, and that could be a door that opens some of these other things under the heading of machine actionable data. The QR code is here if you'd like to look at it. Again, and it's posted on the NIH website. So there are those 5 overarching areas: metadata, persistent identifiers, citation and impact, APIs, and that outreach training area. The focus has been on how to standardize those approaches and develop appropriate training and outreach, and to also spark something in the community that creates a network of people who are working on this and who are forging ahead together. The focus is on providing practical, fair implementation guidance. So while we do talk about and have training that talks about the why and the range of things, it also includes, here's some specific metadata elements that you can adopt. So there's a minimum metadata schema that I'm going to tell you a bit about, and we give examples where our project sponsor said, okay, here is a very good way to do this that is used by many different repositories. If people don't have one, here's one to choose. Something else that was done is we went back to all of the initial repositories that we had done those deep dives with, and we said for these 5 areas, we did an additional mapping assessment to say, here's where you are, here's where the blueprint is, here's how you get to there. And so it gave them a simplified version of that work plan and a way for them to see how to move in the same direction. So that minimal metadata schema, which is a mouthful, and sometimes we refer to it as the core metadata schema, because we don't want people to think, well, let me just do the basics and no more. But what's really nice about it is it says more than just do great metadata, make it standardized, interoperable, etc. It says these are the key elements. And some of these things might seem obvious, but there is data that gets submitted to biomedical repositories that doesn't include, say, the infectious agent, which is a pretty important thing, and some other basic things that if people are focusing on it, might not be difficult to add. So here's an example, and again, this is an example from data people, maybe not malaria researchers, so hopefully if Baron Mons watches the recording, he doesn't zap me too much. That's his original area of research. But if you can imagine a malaria researcher, say a postdoc, who wants to do something with the data that it wasn't the intention of the person who collected it. In this case, there's a lot of people doing what we call geohealth now, right? They look at the intersection of health data and spatiotemporal data, right? So maybe you want to see with a changing climate or with see how things are going and how that affects malaria. And so there is a data ecosystem portal that is put out that looks across these 200 plus different repositories. And right off the bat, when you look at one of these disease pages, you can see, well, there are a lot of different pathogens. If you're trying to look up malaria by the pathogen, there's some variation on how people report that. Malaria is pretty standardized as a health condition, but if you only look by malaria as the health condition, you're going to miss several other data records that are probably about malaria that don't specifically say that. And so data that utilizes that minimal metadata schema can be more easily found by the portal or any other analysis uh, uh, journey. And then you're going to be able to find and get your arms around everything here instead of just this top line. And again, you'd find a more complete picture rather than just the top line or two, or the way that you describe it in your home country. If you're following the minimum metadata schema, you're also including that spatiotemporal data. So now the researcher is able to look at data from a specific location over time. And you could do things like map malaria infections. And these are what we would call, again, in the Barn-Mons tradition, ridiculograms, made up, right? But just for as an example, where you could create a sequence of maps, right? A simulation to show kind of over time what has happened and what are the trends and where are they heading. So just a quick look at this minimal metadata schema, because we spent a lot of time working with Oddset on this. And it's just these two slides kind of show you. So it's not 100 different things. It's a dozen things. And many of these carry over to not just biomedical science, right? Date created, author, funded, funder, measurement technique, pretty basic things. And we've been very deliberate about the suggestions of what people should use if they don't have an idea of what to use or something they might map to. And here again, things that come right out of the FAIR principles, like license, so people understand the usage parameters. And here's that infectious host and agent. Is it a person or a tomato? These are pretty important things for researchers trying to reuse data. Persistent identifier. So hopefully if you signed on to this call, you're already a believer. But in case you're like, what is a persistent identifier? We're talking about a metadata element that describes a digital object, right? Usually looks like you might know DOIs, or you see those Inodo links. It's machine readable code, right? Assigned to a specific object for identification. And you can use persistent identifiers for many different things. In our research world, we see them a lot with papers, but there's many different research artifacts like data management and sharing plans, code, machine learning models, all sorts of things that can have persistent identifiers attached to them. And it doesn't just have to be about the object, it should also be about the person that is creating the object. And so another signifier of persistent identifiers is that word persistent, they last, that it's not something that goes away when the research grant ends because it was just assigned arbitrarily by your own system. So it's not like a database key that is definitely not unique. They're different than URLs, but a related topic. And they're very good for machine actionability and all sorts of other things in the open science principles like reproducibility, discoverability, interoperability. Here's several examples of persistent identifiers that people can use and that we do recommend in our, blueprint. Specifically, we recommend DOIs, for example, papers, or for any digital object research output. ORCID is a great standard for researchers, and in the US, it's required by many of our funders. RORs for organizations, ARCs for different objects. Sometimes DOI is costly for people in the way that you're referring to objects can get quite voluminous, so that's a great place for ARCs. And then a new one that we've been working with to establish in the US that came out of Australia, RAID, which is for research activities that are time-bound, so projects. A little bit more about RRIDs. So these are great for finding the exact resource that you used and for tracking those resources and resolving them. An example of an RRID that you might want to set up is, say, for a facility. In a non-biomedical sense, that could be a telescope, right, an MRI machine. And there's a great group in Boulder, Colorado, headed by Matt Marinick for our project that looks at this PIDs for research and specifically for facilities. So, but the thing about identifiers is they can exist out there. You can have a great plan, but it only works if people implement this plan and show. And so, using ORCIDs and RIDs in particular really to support that discoverability, interoperability, reproducibility. So, citation and impact, that's the fourth pillar in the blueprint. The first question is think about what are you trying to cite and show impact for. One of the key ways that you do this is through some of the other things that we've talked about. And of course, I don't think I stopped to say that persistent identifiers in themselves can be part of that metadata record. So when you've got the rich metadata and you're using those DOIs and the RORs and the RAIDs, this is a way that you can measure things. And allow for that tracking so that's a librarian in your group or someone that has that data stewardship role can actually go out and find all of that. So what we recommend to be able to measure citation is, again, implementing those persistent identifiers, having formal citation examples on your website. Don't make people guess how it should be done. Make it easy. Even better if it's something they can click and copy. And consider these metadata integrations with your citation management tools. So again, you're making it very easy for the people reusing your data to include those citations. APIs. So this is the third leg, and this is, again, a lot of these things that we've talked about, any researcher could do with the data that they're creating. APIs is really, though, more one for just a repository. And this is the basic idea that it is important for a human to be able to access the data, but with the volumes of data that we have, it's even more important that it be accessed by programs. And nowadays, some of those programs are LLMs and feeding things into bigger foundation models. But you can still control who gets this impact, who gets this access via application programming interfaces. And so these have been around a very long time, but there's still many repositories that don't make use of them. So what we recommend a few simple steps that are really best practices with using APIs. They should return metadata that's encoded in a standardized format like JSON LD, having a specific URI structure, letting people do it over HTTP, right? Something that you could do through a web interface. And then very importantly, documenting. We recommend the Open API Swagger specification specifically, but also things like versioning, so that as you upgrade your API, it's backwards compatible for people who haven't caught up yet to your latest version. And here's a little bit more about the workflow of exposing metadata to consumers. So we've got a lot of work left. We are just at the start of this phase 2, where we've pivoted from here are the recommendations, the cross-cutting things. And so we're working on that 5th pillar, which is gathering together the liaisons for the different repositories to create that community feedback loop, because it's only going to be as successful as it is implemented. Otherwise, it'll just be this nice document that sits there. And that's not the goal of the work. It's to have impact. So we are actively soliciting feedback, and we're very interested in your feedback, even though this blueprint is targeted at the NIAID community. We'd like to know how it can help other communities and maybe things that we might have been missing. We're working on training materials, which I'll give you a peek on in the next slide, and other kinds of guides that are needed, standalone and synchronous training. We've also developed a communication and outreach plan so that we are being deliberate with the community we're working with about what are the messages we're sending, are we sending them via the right channels and often enough, and then monitoring so that we have metrics and ways to measure the impact of this work too, and a way to capture success stories. So stay tuned for more on this. I'll have a link to our website at the very end of this so that you can watch. But here's an example of the webinar series that we're about to launch. These are tentative dates and times, but gives you an idea. And let's see, some of these would be a bit late for you. So 12 p.m., that would be 9 p.m. Central. But the 9 a.m., that's only 6 p.m. Central. And these will be recorded. And in some cases, we will create small modules that are standalone that can be used at any time, day or night. So we're going to start out with a deep dive into identifiers, and then one on the core metadata schema, then bringing those two concepts together, how to assess impact, and then a second deep dive on extending the core metadata schema, and then one that gets back to our Go FAIR roots, where the FAIR implementation profiles come from, that path to FAIR, and documenting the choices that your community and your repository has made for FAIR implementation. We'll also be releasing a Data 101 Pathfinder. For many of these topics, there's already very good training out there. And so we're only going to attempt to cover the minimum that's necessary to be able to implement it. But for people who want more of a foundation in any of these topics, point them at some of these excellent existing resources that are out there. And so just a few lessons learned. And again, we're partway through the project. So we've got the lessons learned so far is what the title could have said. It was very important for our landscaping exercise to really do in-depth specific analysis. It didn't take a large sample of repositories, but we did need critical mass before we were able to really know that those generalized recommendations fit the community we were working with. And as I mentioned, I think I already gave you the spoiler. I'd love to see an automated fair assessment tool that worked in many cases, but it's very difficult. We wrote a whole paper, maybe more a briefing. It's long, but it covers the necessary part of the subject. It's called Assessing Fairness of Records-Based Repositories for Enhanced Interoperability. It's out as a preprint, and really discusses when a repository is in a database format, how do you assess that? Because if you look, most of the scholarship out there so far is about here's a file with the DOI attached to it. How do I make that fair? There are power users, and that's at least what we call them in the US, maybe an advanced users, maybe something that's a more accessible label. It's a small percentage of that community. You need to have things targeted towards them so they don't feel like their time's wasted on the basics, but they're not the primary audience that a lot of this should be targeted at. And everything that we do needs to be brought back to earth, not just for people who aren't steeped in the FAIR principles, but many people are busy and they're trying to take in this information and make quick decisions and allocate resources, and they need to understand it quickly. Most groups actually were interested in advice. Even if it wasn't going to change how they had implemented their repository, they were interested in knowing how to map, say, to our minimum metadata schema. And that the cost-benefit analysis should not be given short shrift, that was a very important part of the conversation. Okay, so for more info, we have on the Go Fair US website a page about this project. This is my email address, or feel free to connect with me on LinkedIn. And we have a little bit of time if people have questions. So let me stop sharing and check in with Parul and Chris. Okay, so I see there's a question there in the Q&A.